and welcome back to my channel Maths by Shaish. Today in this video we are going to discuss Cambridge ES and A-Level last few questions of Pure Mathematics 1 from May 2021. It is 970912. So here's the 8th question. The first, second and third term of an arithmetic progressions are A, 3 by 2A and B respectively, where A and B are positive constants. The first, second and third terms of a geometric progression are A, 18 and B plus 3 respectively. Find the values of A and B. So what we are going to do, we have this arithmetic progression and all three terms are given. So if the three consecutive terms are given, we require to find the constant common difference. And common difference means second term minus first term, and it has to be same as the third term minus second term. So if we simplify it, we will get one equation in one relation in A and B, and it is going to be 2A equals to B. We take all the A things one side. 3 by 2A minus A is half A, and this minus 3 by 2A towards the left hand side, it is plus 3 by 2A, and equals, we are left with B, and half plus 3 by 2 is 4 by 2, that is 2, so it is 2A equals B. And from the geometric progression, we have first three terms A, 18 and B plus 3. So in the geometric progression, we have common ratio. So if the ratio is common, we can find second term upon first term. This ratio has to be third term upon second term. So if we cross multiply, we will get 324 equals A plus B plus A into B plus 3. Now from the first relation A and B, we got 2A equals B, so we can write B as 2A plus 3. So we get 2A plus 3 here, and if we open it, it is 2A square plus 3A. Now we will make a quadratic equation, and quadratic equation in A, it is 2A square plus 3A minus 324 equals 0. So it's 324 into 2, so we can use the splitting middle term, or we can use the formula for that matter. It doesn't matter at all, but here it is 324 into 2, so 324 we got from 18 into 18 and into 2, so I split it into two parts with 3 and 2. So we got 27, 3 into 3 into 3, and 3 into 2 into 2 into 2 is 24, and the difference is 3, so we can write, because I use the splitting middle term, so 2A square and minus 324 as it is, and I wrote 3A as 27A minus 24A. Then we take first two terms A common, and then last two terms we have 12 minus 12 common, and then we make it equals to this, equals to 0, A equals 12 and minus 27 by 2. Now in the question, it is given that A and B both are positive constants, so it cannot be minus 27 by 2, so it means A has to be 12, and then B is going to be twice of A, so B is 24. That's how we will find this. Now here's the B part. Find the sum of the first 20 terms of the arithmetic progression. So from the arithmetic progression, from the first part, we have seen A is 12, first term is 12, B is 24, but we require the common difference, and the common difference, if we see the AP, the arithmetic progression, it is A, 3 by 2, A and B, that is 12, 18, 24. So we can see from here the common difference is 6. So sum of first 20 terms is going to be S20, and this formula is n by 2, that is 20 by 2, 2 times A plus n minus 1, 20 minus 1 into D. So it is the formula. We simply substitute it here. We get 20 and 24 plus 19 into 6, then 10 into 24 plus 114, and then 10 into 138, that is 1380, and that's the sum of the first 20 terms. This is the 9th question. The diagram shows part of the curve with the equation y squared as x minus 2, and the lines x equals 5 and y equals 1. So we can see this is y equals 1 line, and this is x equals 3. The shaded region enclosed by the curve and the lines is rotated through 360 degree about the x-axis. So if it is rotated through 360 about x-axis, the volume, of course they are going to ask for the volume, and the volume is pi y square dx. And since if we rotate it, this area is not going to, this volume, this will not form any volume, so we will remove this volume. And for this we have this as y equals 1. So we have two curves directly. One is y square, this y square. So pi, the formula for the volume is pi y square dx. And this for the bigger curve, the above curve, this is y square is x minus 2. And the limits, of course, we are going to find first of all. And the limits we can calculate from here. This is the y equals 1 line, and the y square equals to x minus 2. That is going to be the point of intersection where we are going to get it integrate to find the volume. So for the intersection point, we'll put y as 1, and if we put y equals 1, then it is x minus y 1 square equals to x minus 2. That is only x equals 3. So we got these two values, that is 3 to 5. So we are going to integrate from 3 to 5, y square, pi y square dx, and the y square is for the first one, x minus 2, and this pi square, the another one is the line, that is y equals 1. So we will simplify. Pi y square is x minus 2 and y square is 1 square in this case, and then we are going to simply integrate it. X minus 2, and this is also 1, so we can collect them together because the limits are also same. Pi is common in all, so it is x minus 2 minus 1, that is x minus 3 altogether. So it is x minus 3. We are going to integrate it together. It's linear, so we can integrate directly. X minus 3 whole square upon 2, and then we'll put the limit from 3 to 5. When we put 5 upper limit, 5 minus 3 2, so it is 2 square upon 2. When you put lower limit, 3 minus 3 is 0, 0 square upon 2. So we got only 2 square upon 2, that is 2 only. So it is 2 pi, or we can say 3 into 2 into 3.142. That is still 3 significant figure is 6.28 unit cube. So I hope it is clear. Let's discuss the next one. Here's the 10th question, A part. Prove the identity 1 plus sin x over 1 minus sin x minus 1 minus sin x over 1 plus sin x is equivalent to 4 times tan x over cos x. So we are going to prove it with the left hand side. Left hand side, we can take the LCM 1 minus sin x, or we can say simply use the solve the fractions, subtract it. So we multiply the denominators, 1 minus sin x, 1 plus sin x, and then we will cross multiply 1 plus sin x by 1 plus sin x. It is 1 plus sin x square. Similarly, it is minus 1 minus sin x square. So we will, it is a square minus b square in the numerator. So a square minus b square is a plus b and a minus b. So and denominator is a minus b, a plus b, that is a square minus b square. So numerator, we can see sin x got cancelled in the first bracket, 1 and minus 1 got cancelled in second bracket, and then it is 1 plus 1, 2 times 2 sin x, because there are sin x and plus, it would be plus sin x, so 2 sin x upon cos square x. So it is 4 times sin x upon cos square x. I can break it into two parts, cos x and cos x, so that this sin x upon cos x become tan x, and it is 4 upon cos x. So that's what we got, 4 tan x upon cos x. That is the right hand side, and that is what we have to prove. Now this is the B part. Hence solve the equations 1 plus sin x over 1 minus sin x minus 1 minus sin x over 1 plus sin x is 8 tan x from x between 0 and pi by 2 including. So from first part, we have seen this left hand side is same as 4 tan x upon cos x. So ultimately we got 4 tan x upon cos x equals 8 tan x. So we will cancel 4 and 8. We got 2. So tan x upon cos x minus 2 tan x equals 0. So basic problem here runs, sometimes we commit is we cancel tan x by tan x, but we cannot cancel it because there are chances when we get the roots here. So we will take this to the left hand side, and we got tan x upon cos x minus 2 tan x equals 0, and that is, then we will take tan x common, and we got 1 over cos x minus 2 in the another bracket equals 0. So when the product is 0, we are going to equate them individually 0. So we got tan x equals 0, or 1 upon cos x minus 2 equals 0. So when tan x is 0, we get x equals 0. So for the tan the another value is for this is going to be 0 plus pi, which is of course out of the boundary here. So the only root from here is x equals 0. And when 1 upon cos x minus 2 equals 0, so we got 1 upon cos x equals 2. Cross multiply, we got cos x equals half. And from here we get x equals cos inverse half. And we can either remember or we can do it from calculator. It is going to be pi by 3. So we got two roots. From first we got x equals 0 and then we got pi by 3. So these are the two solutions. And in case when we cancel this tan x, we will get only pi by 3, and then in that case we can lose our marks. So be careful. We should not cancel the terms like that when unless it is constant. Here's the 11th question. The gradient of a curve is given by dy over dx equals 6 times 3x minus 5 whole cube minus kx square, where k is a constant. The curve has stationary point at 2, minus 3.5. So it's given, like first part is to find the value of k. It's given that it has a stationary point at 2, minus 3.5. So when we put x equals 2, it has dy over dx has to be 0 because it's a stationary point. So at 2 minus 3.5 dy over dx is 0. It means x plus 3 times this substitution 2. We are substituting it, so that's why it changes the color. Minus 5 whole cube minus kx square means 2 squared. So we got 6 into 1, 6, 3 to the 6 minus 5, that is 1. 6 into 1 cube minus 4k, that is 4k equals 6, and that is k1, k is 3 by 2. That's how we will find the value. Now it is given, the b part is find the equation of the curve. So whenever we have dy over dx, the curve is just the integration of the right hand side. So y equals integration of the whole thing which we have in the right hand side, and we substitute the value of k because we have solved it. So now integration 6 as it is, 3x minus 5 whole power 3 was there, so it becomes 3 plus 1 4, and then we will divide by 4 and 1 upon the differentiation of this 3x minus 5, that is 3. So 3 1s are 3, 3 2s are 6, and then 2 1s are 2, and then 2 2s are 4. So we got only 1 upon 2 times 3x minus 5 to the power 4. And here similarly 3 by 2 as it is, and x squared integration is x cube upon 3. So 3 got cancelled. We got the final equation as y equals 1 upon 2 3x minus 5 whole to the power 4 minus x cube upon 2 plus c, constant of integration. We should always include a constant of integration when we are doing improper integration, indefinite integration. So now we know that this is the equation and we require to get rid of this c, constant of integration. So the one value is given that at 2 minus 3.5 it has a stationary value. So it has a stationary point, or you can say at that point this point lies on the curve. So when this point lies on the curve, we can substitute these values. Y becomes minus 3.5, x become 1, so we got 3 1 3 x becomes 2 here, 3 2 the 6 minus 5. So when we substitute these values, we will solve minus 3.5 equals this, and c become minus 3.5 minus half plus 4, which is going to be 0. So once we got c equals 0, we'll substitute this value here in this equation, and then that is the equation of the curve. So y equals half 3x minus 5 to the power 4 minus x cubed upon 2 only, and that's the equation of the curve. Now c part, find d2y over dx square. So I copied dy over dx here. So d2y over dx means we are going to integrate it again. Differentiate it again. So 6 as it is, 3 power comes down, and 3x minus 5 power becomes reduced, that is 2, and then we multiply by the differentiation of this, that is 3, chain rule, and minus 3 by 2 was the k value, and then x square differentiation is 2x. So we can cancel these two. 6 3s are 18, 3s are 54, and 3x minus 5 whole square minus 3x. That's the d2y over dx square, the double differentiation, second derivative. Now the d part is determine the nature of the stationary point. Once they have asked to find the d2y over dx square, it means they want you to find the nature of the stationary value, stationary point. So stationary point is 2, minus 3.5. So d2y over dx square, we know that when d2y over dx square x is less than 0, it is maximum, greater than 0, it is minimum. So all we need to do is put these values on the into d2y over dx, substitute this. So we don't have y here, so only x need to be substituted. 54 3 times 2 here, x is 2 minus 5 3 times 2. So altogether we got 54 minus 6, that is 48, which is positive. So since d2y over dx square is positive at 2 comma minus 3.5, so it is a minimum point. So the stationary values, nature of the stationary point is minimum. Here's the 12th question, that is the last question of this paper. The diagram shows the cross sections of 7 cylindrical pipes. This is the cross section, each of radius 20 centimeter, held together by a thin rope which is wrapped tightly around the pipes. The centers of 6 outer pipes are A, B, C, D, E, and F. Points P and Q are situated where straight section of the rope meets the pipe with center A. So this is going to be overlap here. So we have given this. First part is show that the angle PAQ is pi by 3 radian. So we need to find this angle PAQ here. And we know the radius of each pipe. So let's do it. Here we can see this line. So this line and this line, they are going to be parallel anyway. And this is parallel to this. Similarly, this is parallel to this. This is parallel to this, and this is going to be parallel to this, and finally this is parallel to this. So what we get to know, if we have all 1, 2, 3, 4, 5, 6, these 6 triangles, and they are parallel. So if we collect them together, we will see that they are going to form a complete angle. So this total, and all angles are going to be same. So total angle becomes 6 theta, and it will give us 2 pi, and that's why theta equals 2 pi by 6, that is pi by 3, and that is angle PAQ, it is pi by 3. So that's how we will solve this question. There is no rule in this part what is the radius or how much we have included. And B part, find the length of the rope. Length of the rope means we are going to find the complete length here. So first of all, if we have the angle here, it is, let's say, pi by 3, it is given, it is we have solved it also, and this is radius is 20. So if we join the two along this point, so it is going to be 20 plus 20, 40. So this is 40. Similarly, there are 6 40 sides, so we got 6 lengths as 40. So 6 into 40 is the length. Now we have to check the arc. So one arc is here. Similarly, there are going to be 6 arcs, and all the arcs are going to be, and we know the arc length are just r theta when theta is in radians. So we have this arc length as r into theta. There are 6, so that's why we multiply by 6. R is 20, radius is 20, and the angle is pi by 3. So we will calculate 20 plus 120 upon 3 is 40 pi. So we got 24 plus 240 plus 40 pi, which is 365.663 from the calculator. And we can approximate, we can write our answer till 3 significant figure, that is going to be only 366 centimeter. Hope it is fine. Now the C part is find the area of hexagon ABCDE and ABCDEF, giving your answer in the terms of root 3. So we can see these areas, this hexagon become regular hexagon because all the pipes are identical and the radius are 20 in each cases. So it's like why it is going to be regular hexagon, because it's a radius 20, this is also 20, this is also 20, this is also 20. So altogether they are going to be of equal length, 40 plus 60, and all the angles are of course going to be equal. So it is a regular hexagon. And in the regular hexagon, if we join the diagonals, if we make these diagonals, we will get 6 equilateral triangles. This is one equilateral triangle, this is another, and since there are other 4, so 1, 2, 3, 4, 5, 6. So there are 6 equilateral triangles, and we have the angle of the equilateral triangle. Each angle, that is pi by 3, 60 degrees, that is pi by 3, and the side length is 40 here. So all the side lengths are 40. So in this way we can find this area, and that is going to be 6 times area of each equilateral triangle, that is half into AB, that is both are 40 40, and sine of the angle between it, that is pi by 3. So 40 40 and the angle between it. So we will simplify and we'll get it as 2400 root 3 centimeter square. That's the area of this hexagon ABCD. And here's the D part, the last part. Find the area of the complete region enclosed by the row. So it means we are going to find the total area. We already have this area from the previous part, that is going to be, that was 2400 root 3 centimeter square. So all we need to find is this area, and then we can multiply by 6, because this area is going to be same as this area is going to be same as this, and 6 this area, and the area of the sector, of course, 6 times area of the sector. So all things we have already, because for this case this is the width and this is the length. It is a rectangle, so it's like a 6 times area of rectangle, and this is a sector. We have the angle of the sector, so we can calculate this and we can multiply by 6. So it is going to be area without hexagon we are going to find, and then we will add this area of hexagon, so that we get the complete region. So area of hexagon without hexagon ABCDEF, it is 6 times area of sector PAQ, that's what we have seen, plus 6 times area of rectangle, this area. This is going to be same in all the cases. So area of sector, it is 6 already, half of r square theta. R square means radius square, it is 20 square into theta is pi by 3, plus 6 times area of rectangle means length into breadth. And so we will solve it. We got 400 pi plus 6 into 800, that is 400 pi plus 4800. So complete area in this way becomes this area which we have calculated, and we will add the previous area, and we can calculate from calculator directly. It is going to be 10213.559 till 3 significant figure. It is going to be 10,200 centimeter square, and that's the answer for it. And that was the last question of this paper. I hope it was of some help. So let's meet again in the next video for another past paper solution. Till then, thank you so much.